like a happy medium because I think in second hour, I don't think I explained enough. And I think last hour I kind of over-explained. So I'm going to try to find like a middle area. All right, so here's where this section fits in. So this whole chapter, we've been dealing with right triangles. So the first section was the Pythagorean theorem. We've done the Pythagorean theorem a lot. Pythagorean theorem, you know that if you have two sides of a right triangle, a squared plus b squared equals b squared, you can find the third side. The limiting factor of the Pythagorean theorem is you have to have two sides. Okay? So let's say you only have one side. Well, we learned in that last section, which was awesome, and I just got great feedback that everybody really loved it. You only have to have one side, but it either has to be a 45-45-90 triangle or a 30-60-90 triangle. Okay? Because those have specific ratios for the side lengths, you just have to have one of the sides. Okay? So other than that, if we have a right triangle that's not one of those special cases, so far we've had to have at least two sides to find the third. So what we're going to learn today is we're going to talk about trigonometry. So trigonometry is a way to look at right triangles and specific ratios of their side lengths, so you can find a missing side length without necessarily knowing two sides. So with trigonometry, you can get away with just knowing one side length, and you can find the other two. But the thing with trigonometry is you have to know an angle measure. Okay? So if maybe you don't know two sides, but you know one side and an angle measure, these trigonometric ratios can help you find those missing sides. So here's kind of where this comes from. Here's where it works. It deals with why these work. It deals with similar triangles. So a similar triangle or similar figures are going to be figures that are the same shape, but not necessarily the same size. Okay, so they're either going to be bigger or they're going to be smaller. But with similar figures, the side lengths, the corresponding side lengths, are going to be proportional. So like if this side is 4 and this side is 8, right, 4 to 8, that's double. Every other side is going to be double as well. So 3 to 6, 5 to 10. You guys get the idea? Okay, so these trigonometric ratios deal with that. So what this says, let's say we have a right triangle, okay, and I know that one of the angles is 20. Okay, now here's the thing, these only work with right triangles because, although I only know technically one angle measure, I really know all of them, right? Because if this is 90, this is 20, this would be 70, right? So the thing is, with every single right triangle in the entire world that has an angle measure that's 20, the other angle is going to be 70. It doesn't matter how big or how small it is. So the angle measures are all going to be the same. It's going to be 20, 90, and 70. Agree? No matter how big or how small it is. Okay? Well, it turns out that, let's say, if this side was 3, 4, and 5, these are going to be similar triangles. Similar triangles. So if they are similar triangles, it means that their corresponding side lengths are proportional. So if this bottom was 4, and let's say this bottom was 8 like we talked about, so 4 times 2 gives you 8, you could fill in all of the rest of them. 3 times 2 gives you 6, 5 times 2 gives you 10. Okay, so what trigonometry does is it says, okay, let's say I only know this angle measure and one of the sides. I don't have to know all of this information because I know that every single right triangle in the world that has one angle measure of 20 is going to have the same ratio of side lengths. I don't have to know all of the sides. I just have to know one of them. Because if this is 8 and that's 20, the kind of process, I can figure out all of the rest of them. Okay, so there are going to be 3 separate ratios that we are going to talk about that you can use to find the missing side lengths. They are sine, cosine, and tangent. So when you say sine of, what we're going to talk about today is sine of A, you are always going to take sine of an angle. Okay, it's talking about in relation to this angle. And sine of angle A is going to be the ratio of specific side lengths. So when we're wanting to find sine of A, we're looking at this angle right here. Now you don't have to take sine of A, you could take sine of B. We don't want to take sine of the right angle, so you're not going to take sine of C. But whatever we're doing with A, you could also do with B as well. Okay, so let's say we're talking about sine of A. What this is saying is that whatever that angle measure is, they don't tell me, I don't know what it is, but any right triangle in the world that has that angle measure, like down there how it was 20, is going to have the same ratio of the leg opposite over the length of the hypotenuse. So what that means with this angle right here, if you take the ratio of the opposite side, which is A, over the hypotenuse, which is C, that ratio is going to be the same for every right triangle that has an angle that measures that. Okay, and it also works for what's called cosine. So cosine, still of angle A, is the ratio between the length of the leg that is adjacent to A. Now, adjacent means next to, and if you look at angle A, there's actually two sides that are adjacent, right? C and B are both next to it. But C is the hypotenuse, which always trumps the adjacent. Okay, so not the hypotenuse, the adjacent leg is going to be B, okay, over the length of the hypotenuse. So this ratio of B over C is going to be the same for every right triangle that has that angle measure. And then it also works what's called tangent. So tangent would be the length of the leg opposite, which would be A, over the length of the leg adjacent. When we talked about adjacent, is going to be B. So this ratio, once again, A over B, whatever those numbers are, that ratio is going to be the same for every single right triangle that has that angle measure. Okay? So one of the things we're going to be doing today is putting these ratios to work. Now this is kind of a lot to remember, and you have to remember these. Have to remember these ratios, which may seem a little daunting, but there's a really, really easy way to remember them. This is what I was taught in art school. I think they still teach it this way. So how you remember that sine is the length of the leg opposite over the length of the hypotenuse. You're going to do SOH. Sine is opposite over hypotenuse. Anybody know what this is going? Remember this? No? Yeah. Okay. Cosine is the leg adjacent over the hypotenuse. So cosine is adjacent over hypotenuse. And then tangent is the leg opposite over adjacent. So tangent is opposite over adjacent. SOHCAHTOA. That's what you got to remember. SOHCAHTOA. That will help you remember the three trigonometric ratios. Okay? So the first thing we're going to do today is just get used to using these ratios and writing these ratios. All right? So for this one down here, we want to write the sine, cosine, and tangent ratios of angle T. So this angle right here. Remember, we could write all these ratios for angle G. They just asked me to write them for angle T. So to find, let's start with sine of T. We would write it like this, sine of T. Now, my little acronym here, to find sine, we are going to take opposite over hypotenuse. So what that means, in relation to angle T, we are going to take the side that is opposite, which is 8, over the hypotenuse, which is 17. So sine of angle T is 8 over 17, which means, I don't know what angle T measures because they don't tell me, but whatever it is, this ratio of 8 over 17, any triangle in the world that has an angle that measures that is also going to have that ratio of those sides. It will reduce down to 8 over 17. Okay? Now, if we want to find cosine of T, we would write it like this. Now, cosine is the C-A-H. So cosine, the A is adjacent, the H is hypotenuse. So once again, looking at angle T, the adjacent side, not the hypotenuse, it's the other one. So in this case, it's going to be 15 over the hypotenuse, which is 17. So 15 over 17. And then lastly, to find tangent of T. Tangent's going to be that last one, TOA, opposite over adjacent. So once again, looking at angle T, we're going to take the side opposite, which is 8, over adjacent, which is 15. So 8 over 15. Okay, that's one of the things we're going to be doing today. Okay, yes?
All those fractions that we get, like phase fractions, so we'll never have to reduce them?
Not necessarily. You may have to reduce them, yeah. And if you could reduce them, you want to. Good question. Okay, let's get this fluid into page 23. This is section 8.3, trigonometry. All right, so the first thing we're going to do is just practice using the ratios, writing the ratios, and then we'll talk about how to use the ratios to then go ahead and solve for some missing side lengths. So, first ones, keep in mind, these ratios only work with right triangles. Because remember, with the right triangles, if you know you have your 90-degree angle and you have another angle, you can find the third one. So you can establish similar triangles by that way. So let's draw our right triangle. Got a right angle. Okay, angle X is going to be that top one. Angle Y will be the right angle. Angle Z will be the other one. Okay, XY is going to be 8. YZ is going to be 15, and XZ is going to be 17. Okay, so we're just practicing writing the ratios. So if I want to find sine of X, this is where that SOHCAHTOA comes in. So sine is that S-O-H. So to find sine, we're going to take opposite over hypotenuse. Now we're finding sine of X. So we're looking at these in relation to angle X. So the opposite side from X is 15. So we're going to put 15 over the hypotenuse is 17. So to find sine of X, that's all you do, 15 over 17. Okay, to find cosine of X. Cosine, SOHCAH, C-A-H. To find cosine, you're going to take adjacent over hypotenuse. Remember, the adjacent side is the side next to it that's not the hypotenuse. So in this case, it's going to be 8 over the hypotenuse, which is 17. So 8 over 17. And then lastly, to find tangent of X, that's TOA, T-O-A. So to find tangent, you're going to take opposite over adjacent. So once again, in relation to angle X, you're going to take opposite over adjacent. So it's going to be 15 over 8. Okay, that's one of the things we're going to be doing today. And then, like Hank said, if you could reduce those fractions, you would want to. Okay, questions on that one? Okay, so that's super fun and all. Yeah, but that didn't help me find side lengths. Right? So let me show you how we can use these ratios to find the missing side lengths. So number 2. Okay, so let's say we have our right triangle. Okay, we're going to have this angle here, which is 33 degrees. This side right here is X, and this side is 14. Okay, so a couple things you have to do right at the beginning. First of all, you need to find the angle that we're given, because sine, cosine, and tangent are talking about sine of an angle, cosine of an angle, tangent of an angle. So in this case, the only angle I'm given is that one. So we're going to be looking at these sides in relation to that 33-degree angle. Okay? Now what you have to do is decide which of these ratios you're going to use. So, how you're going to decide which of these ratios you're going to use is you're going to look in relation to this angle. I've got 2 sides. I don't know what X is, but we're going to find X. I've got X, I've got 14. So you have to decide in relation to this angle, is that X opposite, hypotenuse, or adjacent? It's opposite of that side. So I have opposite, and then the 14, it's the hypotenuse. And the hypotenuse always trumps the adjacent. So I have OH. So you're gonna look at your ratios. It's that first one, right? It's the only one that has O and H, which means we're gonna use sine. So what you're gonna do is we are going to take sine. Now before we took sine of x, because I didn't know what the angle measure was. I know what the angle measure is. The angle measure is 33. So we're going to take sine of 33. Now what sine of 33 means? It means that any right triangle in the world, any right triangle in the world that has a 33 degree angle, this ratio between the opposite, which is x, over the hypotenuse, which is 14, whatever x is, we'll figure that out in just a second. Any right triangle that has an angle of 33 degrees is going to equal this ratio. So we need to find out what x is. Now I know this looks kind of confusing. We're just solving an equation here. So ignore that sine of 33 over here. If this is x over 14 and I want to solve for x, how could you get rid of it over 14? Yeah, multiply by 14. And we know what we do to one side, we have to do to the other. So this is what I want you to practice plugging in your calculator. What you're going to plug in your calculator is you're going to plug in 14 times sine of 33. Now, if you have a calculator that you only plug in one operation at a time, I don't know if I see any. They're all good. So you all should just be able to plug this in exactly as it is. Oh, sorry, Jake, you do have one. Okay, so you're going to type in 33 and then sine times 14. Okay, when you do this, I want you to make sure you can get the right answer. You should get 7.6. If you did not get 7.6, you need to talk to me because I would hate for you to be able to go through all this work and do all the work and you just can't plug it in your calculator, right? Okay? Anybody have issues getting 7.6? Okay. Okay, number 3. Let's draw another right triangle. Okay, this time my angle is 37. This bottom side is going to be my x. The hypotenuse is going to be 14. So the first thing you have to do is decide which of these ratios we are going to use. So I'm given this angle right here, because remember the sine, cosine, and tangent is in relation to that angle. It's in relation to a 37-degree angle. So in relation to this angle, is that x the opposite hypotenuse or adjacent? It's the adjacent. So I have adjacent and what's the 14? And hypotenuse. So I have an A and an H. So it's the C, right? C-A-H. So we are going to use cosine. Now we are going to take cosine of 37 because the cosine of 37, this ratio of any 37-degree angle is going to be the same regardless how big or small the triangle is. So to find cosine, we're going to take adjacent, which is x, over hypotenuse, which is 14. Just like the last one, solve for x. Multiply both sides by 14. Once again, I want you to practice plugging it into your calculator. You should take 14 times the cosine of 37. You should get 11.2. Once again, if you're not getting 11.2, I need to talk to you to make sure we can figure out how to get that. Did you get that? Okay. Somebody in the last class had that calculator. Okay, anybody else? Okay. Just a couple more. Okay, number 4, another right triangle. Keep in mind all of these only work for right triangles. Okay, let's say this bottom angle down here is 29 degrees. Okay, this side is going to be x, and that top is going to be 3. Now, once again, we're looking at this angle right here. And if I look at the two sides that I'm dealing with, what is this side that the x is on? That's the adjacent. What about the 3? Opposite. So I have an O and an A, which would be OY. OY would be tangent. So we are going to take tangent of 29 And tangent for any angle is opposite, which in this case is 3, over adjacent, which is x. Now, we have a problem here. Because I've got this x in the denominator. Now, it does not matter if you're solving an equation that deals with tangent. If it doesn't deal with tangent, if you're in Algebra 1, Algebra 2, wherever you're at in your life, solving equations and having the time of your life, if you have an x in the denominator and you're trying to solve for x, we have a problem. Because you can't solve for x, it's in the denominator. First thing you gotta do, get it out of the denominator. How can I get it out of the denominator? Yeah, just multiply by x. But what I do to one side, I have to do to the other. Because look what happens here. Those cancel out, so no more x in the denominator. Now on the left, I get x times the tangent of 29. And on the right, I just have a 3. Okay, now, over here on the left, I'm still trying to solve for x. And I know it looks kind of funny because I've got like words and numbers and everything in here. But I'm trying to solve for x. I need to get rid of a times tangent of 29. How can I get rid of times tangent of 29? Yeah, divide by tangent of 29. So, for everybody except Jay, you can just plug this into your calculator. Take 3 divided by the tangent of 29. I want you to practice it. You should get 5.4. So what you're going to have to do, you're going to have to do 29 tangent. And you just have to copy that down because you're going to have to just maybe keep it maybe like 4 or 5 decimals. Because then you're going to have to take 3 divided by that decimal. And your answers may be a little bit off because it's not exactly 2, but you should be close still. Okay, let's try one more of those. Number 5. Okay, so let's say this angle is 55, this angle is 47, and that hypotenuse is going to be x. Okay, so I've got to decide which ratio I'm going to use. So I have the opposite, and I have the hypotenuse. Which ratio is opposite and hypotenuse? Sine. Yeah, so we're going to take sine of 55 equals opposite, which is 47, over hypotenuse, which is x. We have the same problem, right? I can't solve for x if the x is in the denominator. So we're going to multiply both sides by x. So we have x times the sine of 55, and on the right we just get 47. And just like the last one, to get rid of the times sine of 55, we would divide by sine of 55. Once again, I want you guys to practice. Make sure you can get the right answer. You should get rounded 57.4. And if you are not getting that, you definitely need to let me know. Okay, you guys have questions so far? Got one more. Got it, yes.
So for so when you're putting the light box in the like
It's a fence on this. So it would be opposite over hypotenuse. Adjacent over hypotenuse, opposite over adjacent. Yeah. Okay, so last one, we've got a nice little lovely word problem here. So we have an escalator at a shopping center is 200 feet 9 inches long. It rises at an angle of 15 degrees. What is the vertical rise of the escalator round to the nearest inch? You guys are me, I'm the big picture person. Right? You got an escalator. Okay, now. Well, that's a good escalator. Okay, so we've got this escalator. It says it is 200 feet 9 inches long, rises at an angle of 15 degrees. So this right here is going to be 15 degrees. I'm wanting to know what is the vertical rise of the escalator. What am I looking for when you do a vertical rise? Now I have the hypotenuse, don't I?
Height.
Yeah, the altitude, the height. I love these math words. They're great. Yeah, I'm looking for that right there. Now, before I can even figure out the trigonometric ratios, that's going to be a problem. Right, 200 feet 9 inches. What do you think I need to do? Let's turn it all to inches. So there are 12 inches in a foot. So 200 times 12 is 2,400. Plus the extra 9 inches, it's going to be 2,409 inches. Okay, now, in relation to the 15-degree angle, what sides do I have? I have the hypotenuse and the opposite, which is which ratio? Sine. So we're going to do sine of 15. My opposite is x. My hypotenuse is that 2,409. Now the x is in the numerator. No worries there. These are the easy ones. This is solve for x. We're just going to multiply both sides by 2,409. When you take 2,409 times sine of 15, should end up with about 623 inches.